Hi, welcome to our AP Stats notes. Today we're going to be looking at independent events and the multiplication rule. So independent events are independent. Two events, let me change this to red. Two events are independent if the outcome of one event has no impact on the outcome of the other events. So for example, flipping a coin and rolling an even number on a die are independent because if I flip a coin, it's not going to affect whether or not I roll an even number or an odd number. Those are completely independent. Flipping a, I should say, a heads on a coin. Or a tails. It doesn't matter, but either way, flipping heads or tails on a coin is not going to have any impact on the roll of the dice. For dependent events, I could have something like picking an ace out of a deck of cards, not putting it back, and picking another ace. So my chances of getting an ace the first time would be 4 out of 52. My chances of getting an ace the second time would be 3, because there are now 3 aces out of 51. So that would be a dependent event because the odds of the second ace went from 4 out of 52 to 3 out of 51 because I didn't put that first ace back. The probability of A and B, if you see the word and, that means we have to multiply them together. So it'd be the probability of A times the probability of B. So if I wanted the probability of flipping a heads and a tails on 2 coins, you could also say this is the probability of flipping a heads and a tails on 2 coins. It means the same thing. So I could either use 1 coin, flip a heads, and then flip a tails, or I could take 2 coins and see if I get a heads for one and a tails for the other. That probability would be a heads for the first coin is 1/2. The probability of a tails on the second coin is also 1/2. So the probability of a heads on one and a tails on the other would be the same thing as 1/2 times 1/2, which is 1/4. And again, if you see the word and, you've got independent events, then I can use the multiplication rule. So in that first example, because flipping a heads has no impact on the second flip, those are independent events, and I can use this rule. For a second rule, picking a 10 out of a deck of cards and rolling a number less than 6 I could do the probability of picking a 10 times the probability of rolling less than 6. So that would be probability of picking a 10. There are 4 10s in a deck of 52 cards. The probability of rolling less than 6 would be 5 out of 6. So this would be 20 out of, that would be 312. And of course we could simplify that, or we could take our calculators and take 20 divided by 312 and get approximately 6.4%. 6.4%. And then if I wanted to try a third example, I'm going to ask you to try this one on your own using our multiplication rule. Picking a yellow M&M, so assuming these are evenly distributed, what's the probability of getting a yellow M&M? You put it back, and then you pick a red M&M. Out of those 6 colors, the probability of yellow is 1 out of 6. The probability of a red, after I put the first one back, is also 1 out of 6. So the probability of picking a yellow and then a red, if I put them back after I pick them, it's going to be 1 out of 36. Now let's use some of this math to work out some of the problems that we looked at yesterday and the day before. So if I've got my OR question, this is our addition rule, our general addition rule. It was probability of A plus probability of B minus the probability of A and B. And what I want you to see here is that this probability of A and B happening, that's our multiplication rule. So what would that look like in practice? The probability of picking one of the 36 number cards in a deck, probability of a number card, plus the probability of rolling a 5 or a 6 minus the probability of A and B. That's our general addition rule, and this right here, this last part, is our multiplication rule. So what's the probability of picking a number card? That's 36 out of 52. The probability of rolling a 5 or 6 is 1 out of 3, or 2 out of 6. So if I add those up, 36 out of 52 plus 0.3 repeating, we notice that these two together would be more than 1. So this is more than 100% chance, which means there's something wrong. We need to subtract something. We need to subtract the product of 36 out of 52 times 1/3. So this ends up being 0.6923 plus 0.3 repeating minus 0.23077. And that final probability would be 0.795, or 79.5% chance of either getting a number card or rolling a 5 or 6. So there's a pretty good probability that one of these three things happens. Either you pick a number card, you roll a 5, or you roll a 6. All right, let's try another one. Probability of flipping a tails or rolling a number greater than 2. So I need to do our general addition rule, which is the probability of flipping a tails. That's 1/2. Plus the probability of rolling a number greater than 2. That's 3, 4, 5, 6. That's 4 out of 6. If I were to add 2/3 plus 1/2, that's 1.16 or 117% chance that that happens. But I know that can't be true. I can't have more than 100% chance of something happening. So I have to subtract this product of 1/2 times 4/6, which ends up being 2/6 or 4/12 or 1/3. So I have 1/2 plus 2/3 minus 1/3. So it's a half plus a third, which is 0.88, sorry, 0.83333. 0.5 plus 0.33 repeating. It's 0.83 repeating, or 83.3% chance that you would get a tails or roll a number greater than 2. All right. I'm going to stop there. I'm going to upload a second video. If you're going to make this a first part, I'll upload a second part and a third part so that we can keep these short and keep the upload speeds fast.